Laws of nature. So, what exactly do we mean by laws of nature? Well, usually when people think of the word law, they usually think of something similar to like rules or obligations issued by the government or a head of a state. In this sense, laws are prescriptive, which prescribes how people within its jurisdictions are supposed to behave or not behave. However, laws of nature are not prescriptions, but rather descriptions of how nature works. Only conscious beings like us, humans, can prescribe, because only we are capable of giving orders. However, even without human beings like us, the uniformities or the laws of nature would still continue to happen and exist, even without our existence. Here are 3 points that are used to avoid confusion regarding prescriptive laws and descriptive laws. So first, laws should be obeyed. Whether or not you should follow or obey the laws of the land or the laws issued by your government is a problem in ethics and morals. However, laws of nature is not something you can choose to obey or disobey. For example, law of gravitation. You can't choose whether to obey or disobey gravity because it is a law of nature, something that shows how nature works and exists naturally, whether or not we can describe how gravity works. Second is, where there's a law, there's a lawmaker. This statement applies clearly to prescriptive law, wherein if a course of action is prescribed, then someone must have prescribed it. However, laws of nature are different. As I've stated earlier, laws of nature are not prescriptions, but rather they only describe how nature works. Third is, laws are discovered, not made. Meanwhile, this statement only applies to descriptive laws. It means we discovered how nature works, but it doesn't mean that we made it work that way. Only the formulations of these uniformities. For example, gravity and photosynthesis are some examples where humans discovered it to have a clearer understanding of how the world and its nature works. However, it doesn't necessarily mean that since we, humans, discovered gravity and photosynthesis, we made it work that way.
While prescriptive and descriptive laws differ fundamentally from laws of nature, understanding the distinction broadens our discourse and scientific inquiry. Laws of nature aim for universality, inviting exploration across various contexts. A law of nature is a universal statement, typically expressed in the form of all A's are B's, or if something is A, then it is B. Good examples of this law include all objects that free fall on Earth accelerate at 9.8 meters per second, or all living organisms are made up of cells. But if not all A's are B's, then we'd be having a statistical law. A good example of that would be the tagline, Product X removes 99% of bacteria. Commercials advertise it like that, so as to offer a probabilistic understanding rather than an absolute certainty that a product can remove 100% of the bacteria. Things are universal, but if we go into the specifics, that is not enough. If we broaden the statement, all the apples I've seen are red, that doesn't really tell us anything about all the apples that exist. That brings us to our second law of nature, open-minded scope. Now this is universal and does not have any restrictions with time and space. So wherever there is A, it will always be affiliated with B. For example, wherever there is salt, it will always dissolve in water. Another law of nature is that it must be expressed hypothetically. That is saying what will happen when conditions are met, not saying what has obviously happened. For example, the statement all metals expand when heated is not correct because it is possible that some metals may not expand when heated. Now, if it were considered hypothetically, it would be if a substance is a metal, then it will expand when heated. That should hold universally true. As the fourth and last one, the greater the generality of a statement, the more likely it is to be recognized as a law of nature. Scientific explanations help us understand why events occur as they do. Everyday explanations don't always require complex theories, such as answering the question, why is a door open or why is someone absent? Theories can be incrementally confirmed, that means to a certain degree, but they cannot be fully verified. On the other hand, a single counterexample can falsify a theory.
A theory in astronomy. In human history, the Earth being at the center of the universe while the celestial bodies revolved around it seemed such an obvious fact that when anyone thought otherwise was considered mad. So let's go to Ptolemy and Copernicus' theory. Based on the observations he made, Ptolemy saw the universe as a nested transparent spheres, with Earth being at the center of it. He stated that the Sun, Moon, and all the other planets revolved around the Earth. So he incorporated Hipparchus's notion of epicycles. Epicycles are small circular orbits around imaginary centers in which the planets were said to move while making a revolution around the Earth. Meanwhile, Copernicus theorized that the Sun is at the center of the universe, while the Earth revolves annually around it. This is called heliocentric or sun-centered system. A theory in geology. Researchers were curious as to why dinosaurs suddenly disappeared millions of years ago. They found something unusual. A thin layer of clay was discovered laid down seemingly during the period in which dinosaurs became extinct. But in this layer, large quantities of iridium can be found, a metal rarely encountered on the Earth's surface. Another relevant discovery is that outside the boundaries of the solar system is a vast array of comets called the Earth cloud. When the Sun's invisible companion intersects with the Earth cloud, carrying many of its comets, some of which are drawn to the Earth's orbit. The dust from these impacts causes to block the light of the sun, causing the plants and the creatures who feed on them, like the dinosaurs, to die.
The study of the unobservable. When direct evidence is lacking, scientists often hypothesize about unobservable entities. Ancient philosopher Lucretius noted that gradual changes, like worn stone steps or rapidly mixing berries in water, suggest that small particles or atoms exist. Now, with scientific explanations come further inquiries, which often result in brute facts that lack deeper explanation. An example of that would be Einstein's unified field theory, which aims to connect gravitation, magnetism, and electricity. Now that highlights the mysteries of the universe. Emergence is the phenomenon where complex patterns, properties, or behaviors arise from the interactions of simpler components, which typically do not exhibit the same characteristics. Reducibility implies that the patterns, behaviors, functions, or properties of a system can be derived by examining its individual components and understanding its interactions with each other. We often say that animals act to fulfill certain purposes, like when a bird collects materials for its nest or when Arctic animals are white for camouflage. This teleological explanation suggests that living beings possess intent. However, limitations of purpose become evident when concepts like Darwinian survival reveal that traits arise from natural selection.
What does creationism have to do with religious and cultural significance? Well, humans derive a sense of meaning and purpose in life from their creationist beliefs, which are commonly intertwined with the religious perspectives. Now, creationist beliefs typically refer to the idea that life, universe, and everything were created by a divine being, in this case God. For many, this worldview offers a framework for understanding their existence, morality, and place in the universe. The complexity and beauty observed in nature, such as the intricate design of the human eye, is often cited by creationists as evidence of a divine creator. In creationist views, structures like the human eye, with its precise arrangement of components working in harmony to allow vision, are seen as being too complex to have arisen solely through the processes of natural selection, as suggested by evolutionary theory. This belief strengthens their conviction that life is not a mere accident of evolution, but part of a meaningful, purposeful creation that aligns with religious teachings. Supporters of creationism often refer to a religious text, such as the Bible, as providing accurate accounts of the origin of life, believing that these texts offer divine explanations that surpass scientific theories. The Bible is seen as a foundational text that describes how God created the universe, earth, and all living beings. For many creationists, the Bible is not just a religious or spiritual guide, but a historical document that reflects real events. Evolutionism, the belief in the scientific theory of evolution, is supported by a wide array of evidence from various fields such as genetics and anatomy. These disciplines provide insights into how life has changed and adapted over millions of years. This body of evidence supports the idea that life evolved through natural processes, with species gradually changing and adapting to their environment. Evolutionism proposes that complexity in living organisms arose through mechanisms like natural selection, where beneficial traits become more common in a population over time. This view contrasts with creationism, which attributes the origin of life to divine creation rather than natural processes. Through mechanisms like natural selection, organisms develop traits that help them survive in changing environments. Over long periods, these adaptations can lead to speciation, where new species emerge. Environmental pressures, such as changes in climate, availability of food, or predators, drive these evolutionary changes. Over time, this process results in significant changes within a species, illustrating the dynamic nature of life on Earth. Both creationism and evolutionism have strengths that resonate with different groups of people, depending on their personal values, religious beliefs, and views on science. Creationism appeals to those who prioritize faith based perspectives. It offers comfort and purpose through a belief in a higher power. Meanwhile, evolutionism appeals to those who value evidence and scientific inquiry. It resonates with individuals who seek to understand the world through observable data and logical reasoning. This statement conveys the different roles that laws, explanations, and theories play in scientific understanding. Laws describe what happens in nature, explanations provide the why, offering reasons behind specific events or outcomes, and theories offer a comprehensive framework that integrates laws and explanations to deepen our understanding of the natural world. Together, these components form the foundation of scientific knowledge, each contributing to how we understand how the world around us works.